We can work out whether a reaction is going to be ex or endothermic using bond energies. These are values that are being worked out as to how much energy it takes to break a bond. So if I've got a hydrogen-hydrogen bond, that takes 436 kilojoules per mole of energy to break. A chlorine-chlorine bond only takes 242, so that tells me it's actually an easier bond to break, it's weaker. And an HCl bond is 431 kilojoules per mole of energy. If they then give me the equation, I can work out what delta H is going to be. As long as you follow these rules, you'll be fine. The first thing to do, well, what I would do is I would draw these guys out. So I've got an HH, Cl, giving me two HCl molecules, like so. So just draw out. Okay, which bonds am I breaking? So bonds broken. I am breaking, so you break all the bonds in your reactants. What's that? I'm breaking an HH bond and I'm breaking a Cl-Cl bond. An HH is 436, a Cl-Cl is 242. You add them up and it comes to 678 kilojoules per mole. Right, the next thing you do is work out, you add up the bonds that you have made. What bonds have I made? I've made two HCl bonds. An HCl bond is 431. So bond made 2 times HCl, which is 2 times 431, which equals 862. So I've had to put in 678 kilojoules per mole of energy, but I've got back 862. So to work out delta H, it's your bonds broken minus your bonds made, which for us is going to be delta H is 678 minus 862, which equals minus 184 kilojoules per mole of energy. So, if I go back to this diagram here, which is this reaction, how big is this distance here? How much energy did it take to break all those bonds?
678.
678. How much energy did I get back when I made the bonds? 862. And then that distance there is minus 184. Yeah, okay. So delta H is negative, and we now know it to be minus 184 kilojoules per mole. So that's just putting some figures on how big. So my activation energy, based on this model, is 678 kilojoules of energy. Because that was all the energy it took me to break those bonds. But I got out, this is all the free atoms up here, but I got back 862. So that's on your diagram. Don't worry about that too much. The main thing is you're happy with this method. Add up all the bonds that you've broken, take away all the bonds you made. What the most common mistake people make is they forget about bonds. So they rush into it and they don't add their bonds up correctly.